All right, 5.1, we are talking about exponents and scientific notation. Now, exponents are in fact just a shortcut to multiplication. Exponents are natural numbers are shorthand notation for repeating factors. And remember, when you hear the word factors, think multiply, right? Factors are things you multiply together to get your product. So here we have 3 as your base, 4 is your exponent, or you could say 3 to the 4th power is how many people say it. So the bigger number is your base and 4 is the exponent, okay? The exponent is also called the power. It tells us how many times to multiply the base by itself, okay? And we will cover it again, but you should remember that this exponent only applies to this base, the closest number, okay? We'll go over it again, but -3 to the 4th. The 4 does not actually apply to the negative, okay? It only applies to the 3. If it was 3x to the 4th, that 4 would only apply to the x. So -3 to the 4th. Okay, if we have 3 to the 4th is 3 times 3 times 3 times 3. You can just put that into your calculator, right? 3 to the 4th is 81 because 3 times 3 times 3 times 3 is also 81. And then let's talk about this one, -3 to the 4th. Like I said, the 4 is only going to be applied to the 3. Okay, so that's actually -3 times 3 times 3 times 3. Okay, so that's actually -81. All right, if we had 3 times x to the 4th, that's not going to be 3x times 3x times 3x times 3x. It's going to be 3 times only the x. Okay. I kind of just put it back because for x times x times x times x, I don't know what it is, so I can't simplify it more than x to the 4th. But it is not 81x to the 4th, it's just 3x to the 4th. That 4 only goes to the one term closest to it unless there are parentheses, okay? So -3 to the 4th is actually -81. If I put it all in parentheses, -3 to the 4th, then that is -3 times -3 times -3 times -3, okay? And that's different. So -3 to the 4th is a +81, but -3 to the 4th without parentheses is a -81. You see the difference? Because the negative times a negative is a positive, negative times a negative is a positive, so that's just +9 times +9, which is +81. Okay, so make sure you're paying attention to what this actually applies to. Very important. Let me pause. Sorry, it's just like permanently out of focus. Okay. Also important that by the order of operations, exponents are calculated before other operations. So just think about PEMDAS. P stands for grouping symbols, parentheses. So groups first, but then exponents. So do the exponents before you multiply, divide, add, or subtract, okay? Let's talk about the rules for using those exponents. The product rule, the word product means multiply. So the product rule is if m and n are integers, or sorry, if m and n are integers, a is a real number, then a to the m power times a to the n power is a to the power of m plus n. So notice that when your bases are the same, okay? When bases are the same. Okay? The same base, a raised to any power multiplied by that same a raised to any other power you can keep the base the same, add the exponents, okay? So here we have 3 squared times 3 to the 4th. We have the same base, so a is 3, m is 2, n is 4. That means we keep the base, and then we say 2 plus 4. 3 to the power of 2 plus 4 is the same as 3 to the power of 4 plus 2 is 6. Okay, let's check that. 3 to the 6th is 729. 3 squared times 3 to the 4th is that same number, okay? Also, make sure you know how to find the caret button on your calculator. Even if you're using an online calculator, the caret button is the one that helps you to create exponents in the calculator. That's going to help you. If not to create your answers, then to check your answers, okay? So you could also write it as 729, but they just asked us to simplify, so that's simplified following the product rule. Here we have z to the 3rd times z squared times z to the 5th. Again, we have the same base, and then we'll add the exponents. 3 plus 2 plus 5. 3 plus 2 is 5, and then plus 5 is 10, so that's actually just z to the 10th, because 5 plus 2 is 7, plus 3 is 10. Here, okay, let's think about what you do when you have a coefficient, a variable, and exponents, okay? Generally, the coefficient, which is just the number in front of the letter, the coefficients are multiplied together, okay? So make sure the numbers are multiplied together, and then you can take those letters or the variables and multiply those together. Okay, you can even write them before you multiply them. So in that case, we have 3 times a negative 4. And then the y's are, we're still going to multiply, right? Because it's 3 times y squared times negative 4 times y to the 4th. Y squared times y to the 4th. So you see what I did there? I just put them in order so that I could multiply the number with the number and the letter with the letter. So 3 times a negative 4, 3 times 4 is 12, right? And a positive times a negative is a negative. And then y squared times y to the 4th is just like z, okay? So it's keep the base, add the exponents. 2 plus 4, which becomes, keep that negative 12, and then times y to the 6th. And that's as simple as we can make it, okay? Please notice again that the 2 is only with the y. The 2 is not with the 3. The 4 is only with the y. The 4 is not with this negative 4, okay? And this multiply, it really just means you could write it as 3 times y squared times negative 4 times y to the 4th. There's really no difference between these parentheses and just being side by side in this case, okay? So you're just doing that. You're rewriting it like that. And then I rewrote it with the numbers first, letters second, and then I simplified the numbers to negative 12 and simplified the letters using the product rule. And this is what I got. 3 times negative 4 is negative 12. Y squared times y to the 4th is y to the 6th. The 0 exponent is just something to memorize, okay? A number or a letter to the power of 0 is always going to be 1, no matter what that number or letter is. Remember that this exponent is only going to apply to the a, okay? So 3 to 0, any number to 0 is 1. Negative 3 to the 0, is that going to be 1 or is that going to be negative 1? It's going to be negative 1, right? If it was parentheses, it would be positive 1 because negative 3 to the 0 power is 1 because that's a whole entity. However, if it's negative 3, that means that the 0 is only applying to the 3 and not the negative sign. So the negative sign is going to be out in front of that 3 or that 1, okay? Let's do it again. Negative 3 to the 0 is negative 3 to the power of 0. Negative 3 to the power of 0 is 1, right? We know that. 3 to the 0 power is 1. So it's negative 1. That's how we got it, if you're wondering. All right, how are they different? The parentheses. These parentheses means that I can take all of it and raise it to the 0 power. Without the parentheses, I have to respect that this negative is not part of the exponent, okay? So 5 to the 0 power is just going to be the number 1, right? X, Y, Z to the third, all to the 0 power, also going to be 1. Okay? Negative X to the 0 power is going to be -1 because it was negative X to the 0. The 0 only applies to the X, so that becomes negative X to the 0 power is 1, so that's -1. Okay? For this 0, the only base is the X. It is not the negative sign. Any non-zero number raised to the 0 power will equal 1. Okay? Not if it equals 0, but any other number, and that's 1. Your answer is going to be 1. All right, quotient rule. Quotient means the product of division, okay? It is the answer to a division problem. So we still have A, we still have M, and we still have N, okay? If A is a non-zero real number and M and N are integers, then A to the M power over A to the N power is the same as A to the power of M minus N. So because we're dividing, we're going to subtract the exponents, and we have to make sure your base is the same, okay? So let's say it again. If you have a base raised to a power divided by that same base raised to a power, you keep the base, so keep the A, and subtract the exponents, M minus N. You start with the number on top, okay? Start with the numerator, go to the denominator, because adding, it doesn't matter the order, but subtracting, it does matter the order, right? If I had 2 plus 5, that would be 7, the same as 5 plus 2 is 7, right? So when we're adding, the order doesn't matter. However, if we were subtracting, 2 minus 5 is -3, 5 minus 2 is +3. So make sure that your numerator or your first term is the first term we subtract, okay? So 6 to the 10th divided by 6 squared is, keep the base is 6, take M, subtract N. 6 to the power of 10 minus 2, which is 6 to the power of 8. All right, you can do it in your calculator. 6, just to check, oops, sorry. 6 to the power of 10, it's gonna be a big one, good. Divided by 6 to the power of 2. We get 1679616 as our answer here. Is that the same as 6 to the 8th? It is, okay? So if you have a whole number or a number, you can check it in your calculator. These you can't really check. You just have to trust that you know what to do. So we keep the base, we take that numerator and we subtract the denominator and we get y to the 4th. All right. Here, again, when we had, when we had 3 times -4, we multiplied the numbers and then we multiplied the letters. So let's do the same when we're dividing, okay? We're going to take 36 and 9, and we're going to say 36 divided by 9 is, and we just hope it's a whole number. And in this case, it is. It's 4. That 4 goes on the top, okay? X to the 5th over X. Now we have 4, X to the 5th over X. That X is an understood X to the first power, right? If there's no exponent, it's just that number raised to 1. Because if it was, we've used 6 a lot. If it was 4, 4 to the first is just 4. So X is the same as X to the first. Good. So we have 4X to the 5th over X to the first. Just like here we said 6 to the 10th over 6 squared is 6 to the power of 10 minus 2. We're going to say X to the 5th divided by X to the first is just X to the 5th minus 1, which is X to the 4th. Okay, so we have this 4 from 36 divided by 9 is 4. And then we have x to the 5th minus x to the 1 is x to the 4th. 10 divided by 15. 10 divided by 15, let's separate it out. 10 divided by 15, a to the 7th over a to the 5th, and then b to the 9th over b to the 9th. You can do it all separately, okay? 10 divided by 15 is 2/3. Why? Because I can divide them both by 5. 10 divided by 5 is 2. 15 divided by 5 is 3. Okay? So 10/15 becomes 2/3. A to the 7th over a to the 5th looks just like this one, okay? It's not any more confusing than that. So we're just going to call it a to the power of 7 minus 5. And then we have b to the 9th divided by b to the 9th. So now my base is b, and I'm going to say 9 minus 9. Good? So let's rewrite that again. We have 2/3 a 7 minus 5 is just a squared, and then b 9 minus 9 is not 1, right? It's 0. And remember, anything to the power of 0 is 1. So a squared times 1. That b to the 0 power became 1, and 1 multiplied by all of this just keeps all of this, right? 2/3 times 1 is just 2/3. All right, so I'm going to call this 2/3 a squared. Okay. You can also call it 2a squared over 3. So that a squared can go behind it, behind the fraction, or on the top of the fraction. Okay. Negative exponents. If a is a real number other than 0 and n is a positive integer, then a to the negative n is the same as 1 over a to the positive n. So what is important here is that we always leave our answers with positive exponents. Always convert to positive for your final answer, okay? Here is how you convert to positive, because they're going to ask you to do it, okay? Just like we have been practicing reciprocals. So like the reciprocal of 1/5 is 5, right? Okay, the reciprocal of a to the negative n, well, it's not the reciprocal, but moving it, what the reciprocal does is it moves across the fraction bar, right? From the bottom, 5's on the bottom, now 5's on the top. If I want this to become a positive integer or a positive exponent, I need to move it to the bottom of the fraction, all right? 5 to the power of -1 is 0.2. 1 divided by 5 to the power of 1 is that same number, okay? So when you have a negative exponent, what you're doing is you're saying 1 divided by that base raised to that exponent is equal that negative exponent, okay? So 3 to the power of -2, simplify and write with positive exponents only. You're just going to move it across the fraction bar, okay? There's no fraction, make a fraction. 3 divided by 1 is still 3, don't worry, okay? So I made it into a fraction. Now I'm going to move this across the fraction bar. That's now 3 to the positive 2 in the denominator. It was in the numerator, now it's in the denominator. There's nothing to put up here. We just put the 1 up here, okay? 1 divided by 3 squared. Same here. Turn it into a fraction and then send it below the fraction bar. Here, remember, we've said it a few times already, this -4 is only going to apply to the term closest to it, the single term closest to it, okay? So I'm going to leave 2 up here because he is positive. He doesn't have any negative exponents. Even if he was a -2, wouldn't matter. What matters is the exponent negative? 2 has no exponents, so it stays on top, but x to the -4th, we want to move just x to the -4th down here. If I move it across the fraction bar, the negative becomes a positive. So 3 to the -2nd power becomes 1 over 3 to the +2nd power. X to the -7th becomes 1 over x to the +7th. 2 times x to the -4th, this is very important, the 2 stays on top. The x to the -4th moves to the bottom of the fraction bar, or below the fraction bar, I should say, and it becomes x to the +4th. 2 is on top, x to the 4th is on the bottom. Let's simplify and write using positive exponents only. -x to the -3rd, okay? -x to the -3rd. Remember that if I was going to rewrite this, without parentheses, that negative is not part of the -3, okay? And I have a -3 as an exponent. That means I need to move my single base of x down here, okay? So that becomes x to the 3rd over down here, and I can leave a 1 up here. The whole thing is negative, or that 1's negative, either way, okay? It's a -1 over x to the +3. -3 to the power of a -2. Again, the negative is not part of the base, so we're only going to move the 3. So that is -3 to the power of -2. Again, we're going to move it across the fraction bar, just the 3. So that becomes -1 over 3 squared, okay? You can write it as -1 over 3 squared, or negative out in front, 1 over 3 squared. It doesn't really change the value. Good. You could even write it as 1 over -3 squared, just because that is true. But you do want to remember that you really only want to move the one term. This only goes with x. This only goes with the 3, not the negative. Now it's going to go with the -3. Okay. So now we have, oh, sorry, I can simplify this one further. -1 over 3 squared. 3 squared is 9, right? So -1 over 3 squared is -1/9. Okay. -1/9 is going to give you the same as -1/9, or 1 divided by -9. They're all going to be the same number, okay? -3 to the power of -2. Let's start here, okay? -3 over 1. All of that's being raised to the -2, so I need to move all of it. So now I have 1 over -3. Now it's a +2, okay? Just like this was a 3 to the 2 becomes 9. Look at this. -3 squared. It's a +9 because -3 times -3 is a +9. So 1 over -3 squared is 1 over +9. So that's the difference between outside the parentheses and inside the parentheses. One's a negative, one's a positive. Now we have them on the bottom of the fraction bar, and we're just going to move them up. So this is now x to the 3rd over 1, which is just x to the 3rd, okay? This one, y to the -4th, is going to go up, but x to the -2 is also going to go down, so we're just going to switch places. We have x squared on the bottom, and we have y to the 4th on the top. Good. So it's y to the 4th over x squared is the same as x to the -2 over y to the -4. Let's keep going. Just general practice, simplifying and writing using positive exponents only. So here we have the same base of m, keep the base, and then take the top of the fraction, the exponent from the numerator, subtract the exponent from the denominator, and we get m to the negative 10th. We're not done yet, are we? It's a negative. I want it to be a positive, so I want to move it across the fraction bar. So finally, our final answer is 1 over m to the 10th. Okay, I'll show you another way to see that. I have 5 m's, right? M to the 5th just means I have 5 m's on the top, and I have 15 m's on the bottom. Okay, sorry, I didn't want to waste your time. What it means is if it's common to the top and the bottom and they are all being multiplied, I can cancel them out. So I can cancel out 5 from the top and 5 from the bottom. There's nothing up here, so that's just a 1. And then I count up my m's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. M to the power of 5 over m to the power of 15 becomes 1 over m to the power of 10. There were 10 left on the bottom, or I subtracted them and moved them across the fraction bar, whichever looks easiest to you, okay? So again, here we have 4, 2 over 4, 5. So that's 4 times 4 over 4, 5 times, right? I can just cancel those. I can cancel out 2 from the bottom, and I get nothing on the top, so that's a 1, 4 to the 3rd on the bottom. 4 to the 3rd, oops, sorry, 4 to the 3rd is 64. 1/64th, okay? Or I can use the rule 4 to the power of 2 minus 5 is 4 to the power of negative 3, which is 1 over 4 to the power of 3, okay? Whichever is the easiest way for you to get there. No wrong answers. Now we have y to the negative 10 times y to the 3rd. We keep the base of y. Negative 10 plus 3 is negative 7, but I don't want a negative, so I'm going to move it across the fraction bar, right? I have to move it across, and I get 1 over y to the 7th. Q to the 5th divided by q to the negative 4th. That means I keep the base, and I say 5 minus negative 4, which is minus a negative is a plus, 5 plus 4, which is q to the 9th, okay? Because if that was up here, it would be a positive, and I would just be adding 5 plus 4 is 9. All right, letter E asks us to divide, and remember, you can separate it all out. 10 divided by 20, x to the negative 8 over x. Remember, that's an understood 1. If there's no number, it can just be a 1. And then y to the 5th over y to the negative 5th. That's funny. So 10 divided by 20, I can divide them both by 10, and I get 1/2, right? So that becomes 1/2. Negative 8 minus 1. Oops, minus 1 is negative 9, right? And then y to the 5th minus 5. But 5th minus negative 5. 5 plus 5 is y to the 10th. Okay, let's write that all again. We have, there's a 2 on the bottom, right, from that 20. There's a 1 on the top, but I don't really need a 1, right? 1 times x to the negative 9th is just x to the negative 9th. So I only put the 1 up there if there's nothing else up there. But 1 times x to the negative 9th is just x to the negative 9th. So I'm not going to write that 1. Y to the 10th. One more thing I need to do. I cannot actually have that negative 9 up on top. So that was my answer, but I'm going to move it down with the 2, okay? So I'll rewrite it one more time. So I have only y to the 10th up here. If I had nothing up there, I would write 1, but I'm going to leave off my 1. 2 times x to the 9th. It was a negative 9, so I took it across the fraction bar. Now it's a positive 9. So that becomes y to the 10th over 2x to the 9th. Good. All right, over here we have 4 is my only number, so I'm just going to leave it as a 4. X, -1 plus 5, right? Because I'm multiplying them. The base is the same, -1 plus 5 over x to the 7th is 4x to the 4th over x to the 7th. Now I'm going to take that x to the 4th minus 7, right? When I'm dividing, I'm subtracting x to the -3. So that is now this 4 x to the -3 is the same as, I need to now move that across the fraction bar, 4 on top, x to the 3rd on the bottom. Okay, or remember, x to the 4th means there are 4 x's. X to the 7th means there are 7. And then I just cancel 4. I have none on top and I have 3 left on the bottom. So that's x to the 3rd on the bottom. Good. Okay. Example 8 asks us x to the power of 2a times x to the power of 3. That's the same base, so we keep the base the same. 2a plus 3. We're adding them together, right? When you're multiplying exponents, you're just adding them together. This is not really going to show up, so don't. If you're, this is not going to show up. X to the power of 2t minus 2 divided by x to the power of t minus 5. So I'm going to take that base the same, 2t minus 2 minus t minus 5, right? So it's just practice in combining like terms. Here we had no like terms, so we left it alone. But here I can combine some like terms. So that's x, 2t minus 2 minus t plus 5. So that becomes 2t minus t, right? 2t minus t is just t. And then -2 plus 5 is just 3. So it's x to the power of t plus 3. Those are the exponents. And then let's go on to practicing a little bit of scientific notation. Okay, just introduction to scientific notation. What scientific notation is it doesn't come up a lot in math, but in algebra, but it comes up a lot in chemistry. So if you have a chemistry class that you have not taken yet, this will come up. It is a way to express a number as a product of any single digit number and 10 to a 10th power. Okay. We use it to express large or small quantities. For example, if you have the number 76,300, what you're going to call it in scientific notation is 7.63 times 10 to the 4th power. All right. Let's see what 10 to the 4th power even is. It is 10,000. What we did to 10 we took 10 and we moved the decimal place 3 places. All right, let's just look at this. 10 is equal to 10 to the, let's call this 10 to the 1st is equal to 10. 10 squared is equal to 100, right? It's 10 times 10. 10 to the 3rd is 1,000. 10 to the 4th is 10,000. Okay, so what I'm doing is I'm taking 7.63 and I'm multiplying it by 10,000. 7.63 times 10,000. Another way to think about it is I'm going to take a very large number, I'm going to express it as the first digit, and then I'm going to multiply it by the number of digits I had to move the decimal point. Okay. So 2,560,000 is 2.56 times 10 to the power of 6, because 10 to the power of 6 is 1 million. Good. So 2.56 times a million is 2.56 million, right? That is the original number. That's how you would write it in scientific notation. I moved the decimal point 4 digits. Okay. Here I have a so these are very, very big numbers. Here are very, very small numbers. It's just a way to save space. Okay. So I have 0.000055. It's the same as 5.5 times 10. Instead of to a positive exponent, we're going to use a negative exponent. So 10 to the negative fifth is, oh, sorry, my calculator won't do it. 0.00001. Okay. 10 to the negative third is 0.001. So when I have 0.009, I can also call it 9 times 10 to the negative third. How can I do that? All right, how to write decimal number in scientific notation, followed by how to write a whole number in scientific notation. The whole numbers are the big numbers. The decimal numbers are the small numbers. Okay? All right, to write a decimal number in scientific notation, from decimal notation, which is this, these are decimal notation. From decimal notation, move the decimal point to the right, placing it in the first non-zero digit. Okay, so I'm moving the decimal point to the right. Look at this picture, okay? We have 0.0000987. Here is my first non-zero digit. That's that same digit there, okay? So what I'm going to do is I'm going to count from where the decimal point actually is. 1, 2, 3, 4, 5 times. I had to move until I got to after the first non-zero digit, okay? I moved it 5 times. So I'm going to multiply it by x to that number, okay? It's small. The exponent of 10 will be the number of places the decimal point was moved. It was moved to the right. Think about moving to the right. It was moved to the right. So that is a negative number. Okay. So here, let's count this. -5. Sorry, I didn't really finish this one. We were counting this. 1, 2, 3, 4, 5. I made it from a very small number to a whole number, right? So I'm going to multiply it by 10 to the negative fifth. 10, no, that's not going to work because my calculator. All right. 9.87 times 10 to the negative fifth is, all right, so the important thing to understand is if the decimal point was moved right, it's going to be negative. Okay, think about, remember that the word right, I moved it right, has the word, has a G, the word negative also has a G, okay? We're moving it right, it's gonna go negative. I had to move this right, my exponent's gonna be negative. Let's do this one. 1, 2, 3, 4, 5, don't stop there, go past it. 6, okay? After the first non-zero digit. Okay, I had to move it 6 places. So that's how I'm going to get that number 6. If it went right, it's negative. Negative because it was moved right. Okay, 4 to the negative 8. 4 times, sorry, 4, I'm not even reading it correctly. 4 times 10 to the power of a negative 8. Let's think about that. 4, my decimal point's right here, okay? It's already been multiplied by 10 to the negative 8, so let's move it 8 places forward, right? So there's 1, 2, 3, 4, 5, 6, 7, 8. Okay? 1, 2, 3, 4. And in fact, that usually just means you have 7 zeros in front of what was your original term because we had to move that term and then we had to move the additional 8. Okay, is that what they got? Yes, 7 zeros in front for 4 times 10 to the negative 8. All right, 2 times 10 to the negative 9th. That means I'm going to take this 0.2 and I'm going to, or sorry, this 2, and I'm going to put 9 in front of it. 9 place values in front of it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that was undoing it. So we moved left, right? But you're undoing something that already moved it 9 places. Okay, so this is 0.00000002 is the same as 2 times 10 to the negative 9th. Okay. To write a big number in scientific notation, we're going to go left, right? Left, think positive exponent. Okay? If you had to move left, you're going to make your exponent a positive. So from a whole number, move the decimal point to the left, placing it after the first digit. It's going to go after the first digit. It's here right now. We want it here. How far did it go? Okay. The exponent of 10 will be the number of places the decimal point was moved, just like for the small numbers, but it will be positive because it was moved left. It will be positive because it was moved left. All right. So the decimal point is currently right here. We're going to go 1, 2, 3, 4, 5, 6. Again, we're stopping when we have 1 digit in front of it. So that was 6 places we moved. So that becomes 7.23, don't include the zeros, times 10 to the positive 6th. 4 times 10 to the 8th, think of a very big number, okay? 10 to the 8th is 10 times 10 times 10, 8 times. So that's 4, my decimal points here, and I'm going to add 8 more decimal points. 1, 2, 3, 4, 5, 6, 7, 8. Good. So there are 8 zeros behind the 4. Notice that there are 7 zeros in front of the 2, or sorry, 8 zeros in front of the 2 if it's negative 9. That's because we had to account for the 2. Okay. But you don't have to account for the 4, right? We're just going straight back. So it's actually 8 zeros. So we're going left when it's positive, or we're undoing left positive. Okay. So think about when you're undoing 10 to the negative 4th, negative is this direction on a number line, right? Here's 0. Here's all my positive numbers. Here's my negative numbers. When we're undoing it, Negative fourth goes to the negative direction. Okay. When we're undoing it, positive 12 goes in the positive direction. So 3.1 times 10 to the 12th, I'm going to go 12 in the positive direction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Here I have 1, 5, 9, 3, 0, 2, 5, 6, 2. 10 to the negative fourth. My decimal point's right here. I'm just going to go 1, 2, 3, 4 in the negative direction. So I have 15930.2562 as my answer. Okay. Now let's express these in scientific notation. All right. 0.00125. I'm going to move the decimal point 1, 2, 3, 4 places. Oh, no, sorry, only 3 places. Don't keep going. Stop after you get to your first digit. Okay. So I went 1, 2, 3. Which direction? So it's going to be 1.25 times 10. How many did I move? 1, 2, 3. And I moved right, so it's going to be a negative. I moved right, so it's going to be a negative. Okay. Here, how many do I need to move? Here's my decimal point. How many do I need to move? 1, 2, 3, 4, 5, 6, 7, 8, 9. Stop when you get to your first digit. So it's 2 times 10 to the 9th. I moved left, so it's positive. Here we moved right, so it's a negative. All right, again, decimal points here. I want it right in front of the 7, or right behind the 7. 1, 2, 3, 4, 5. 7.96. Don't leave off any of the numbers unless there's 0. Times 10. How many did I say? 1, 2, 3, 4, 5. We went left, so it's positive. Also, just think about positive means you're multiplying by 10. Negative means you're dividing by 10. All right. So if you're dividing by 10, you're going to get a tiny number. If you're multiplying 10 by 10, you're going to get a big number. Negative exponent means divide. Positive exponent multiply. Negative exponent divide. All right. So if you have a small number, it's going to be a negative exponent. 872, that's a small number. We're still going to do it though. 1, 2. So it's 8.72 times 10 to the second. We went to the left. We're multiplying 8 times 100, right? 90, I can still move that. That's 9 times 10 to the first, or just 10. And I went left. All right. 27 times 10 to the third. Oh, let's switch this one up. So 10 to the third. Think about my number line. When you're converting back, think about your number line. So 27, here's my decimal point, 10 to the third. 3 is positive. So I'm going to go 1, 2, 3. Okay. So that's 27,000. And then you want it back into scientific notation, maybe? Then you can go 1, 2, 3, 4. 2.7 times 10 to the fourth. 281 times 10 squared. We have 281 times 10 to the 10 squared. My decimal point's here. I'm going to send it 2 more back because I'm multiplying it by 10 squared is 100. 28100, which becomes 2.81 times 10 to the 4th. Okay. Here, we're going to go right? It's a very small number. 1, 2, 3, 4. Oh, no, sorry, just 3. I keep doing that both times. 1.79, just go after you get to your first digit, times 10. We went right, so it's a negative. Ten to the negative 3. Okay. Here we're going to go 1, 2, 3, 4, 5. We're going to stop right when we get to the 7. 1, 2, 3, 4, 5. Good. Let's rewrite this one. 367 times 10 to the negative 3. 367, my decimal point's right here. We're making it smaller, right? We're multiplying it by 10 to the negative third. That's the same as dividing it by 10 to the negative third. So we're going to go back 3. 1, 2, 3. So it's 0.367. And then if I wanted to write that as a in scientific notation, I would just move it 1. So I would say 3.67 times 10 to the negative 1.